Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. My name is Muhammad Abid bin Rosdi, and today I will present about my final year project 1, which is the title is Fertigation of Plant with IoT-based System for Management and Monitoring, supervised by my supervisor, which is Dr. Muhammad Shamian bin Zainal. So this is the contents that will fulfill my slide share, which is started with introduction, next to the literature review and methodology, and finally final year project to planning. Now I will start with the chapter 1, which is introduction. So we will start with project background. By linking physical things, sensors and software systems, IoT technology has redefined agriculture, enhancing output, efficiency and sustainability. IoT-enabled fertigation system improve plant development, energy efficiency, and economic advantages by allowing for precise water and nutrient control. Meanwhile, the traditional process often results in water and fertilizer waste, leading to the implementation of IoT-based solutions for effective and sustainable operation. Next, final year project 1 Gantt chart. So as you can see, all of this planning to do the activities week by week works by managing my time properly. Then the problem statement for this project. Traditional plant fertigation system, which rely on employees or follow fixed timetables, frequently result in insufficient water and nutrient management, unstable fertilizer delivery, and poor plant development. So in conclusion, a precise, continuous monitoring system with remote access and control over the fertigation process is required. Now we go proceed to the objective of this project. So first thing first is to compare the most recent fertigation approach using IoT that may utilize to assist and simplify the user in monitoring and controlling. Secondly is to design and assemble an IoT system that can help the farmer to monitor and control efficiently. And lastly, to test and evaluate the proposed framework or method for fertigation system. Next is project scopes. So firstly is deploy a various sensor to remotely monitor the parameter of soil, water and air. Secondly, an IoT-based system is used to monitor fertigation plants that are placed in an open space or outdoors. Now we will go through to the chapter 2, which is literature review. Now we start the chapter 2 with study on the existing fertigation system. Before beginning this project, considerable research was conducted to ensure that this project is better than the existing system. The research is based on the journal articles, thesis, and reference book on the fertigation system and how automation is used in it. The technologies used in previous studies that are relevant to the project scope are marked as reference. This is related previous project 1, which is the title is Design and Develop a Modular Fertigation System for Domestic Usage. So as you can see, on the left we have the simulation of the project, and on the right we have the flowchart of the project. Now description of the previous project 1, which is the author is using SolidWorks to provide the simulation for this project. To acquire an accurate analysis of this project, engineering tools such as SolidWorks are necessary. Following that, a prototype model based on the concept is created for testing, and the actual concentration of the fertilizer solution is tested, and the suction flow rate at a certain pipe flow rate is determined. Next, we go to related previous project 2, which is for the title is Automated Photovoltaic Irrigation and Monitoring System with Internet of Things for Fertigation System. So on the left, we have the pictograph block diagram of this project, and on the right, we have the flow chart of the project. And the description of the previous project 2 is the author describes the functionality of the system which is to design and build the automated system with IoT capabilities and a monitoring system that runs on solar energy. The prototype will show how the complete system operates. The complete prototype, which contains the solar system components, several sensors, and an ESP8266 microcontroller unit, will be important in the implementation of the system. The microcontroller is essential for handling the whole system from receiving the data from sensors to autonomously operating and monitoring the system via Blink, an IoT monitoring platform. Next, related previous project 3, improvement of fertilizer control system for 3 tanks reservoir. This is the description of the previous project 3, which is the author expressed the following Arduino setup, which is the controller that must program to construct an effective fertigation planting system. The Arduino Uno is utilized as a control system, storing the code for managing the electric conductivity and pH value. The controller analyzes the value of electric conductivity and pH using the closed-loop method to guarantee the mixing fertilizer is within the intent range. A timer setting on the Arduino Uno may also be programmed to manage the irrigation time and operate the system automatically at the appropriate preset time. Next, related previous project 4, automated fertilizer mixer system for fertigation farming. The description of the previous project 4 is the designer describes the functionality of the project, which is the integration of inputs, outputs, and the microcontroller. The ultrasonic sensor detects the level of water in the main tank and transmits 2 input signals, one for mid-level water and one for when the water reaches the maximum level of the main tank. After the sensor identifies the mid-level of water in the main tank, the servo motors engage. Based on the input value, there will be a delay before the server recloses after it has been opened. Last but not least, related previous project 5, development of an IoT-based automated fertigation system. And for the description of the previous project 5, the author explained about the flow of the project, which is the drip irrigation system consists of 2 reservoirs connected by PVC pipes, one retaining tap water and the other with a 30 mg per liter urea, which is nitrogen solution. Each reservoir is linked to a solenoid valve that controls the flow of liquid as needed. The solenoid valve outputs were coupled to a T-joint connection, the output of which was attached to the drip line, which provide a drip emitter via which water could be fed to the crop. Now for the table of comparison for those previous projects, and as we can see, there are advantages and disadvantages for all the previous projects that I mentioned before. So firstly, for the design and develop a modular fertigation system for domestic usage. The advantages of this project is customizable and scalable. Secondly, efficient resource utilization. And for the disadvantages is it is expensive and maintenance and system complexity. And second one, for the project previous project 2 is automated photovoltaic irrigation and monitoring system with Internet of Things. So the advantages of the project is conservation of water and scalability and adaptability. And for the disadvantages, requirement for preservation, sunlight reliance, and the initial investment. Next, for the previous project 3, which is improvement of fertilizer control system for 3-tank reservoir. So the advantages of this project is precision and accuracy have been improved, time saving, automation, and decision making based on data. And for the disadvantages is the initial expense, technical difficulty, and power and connection dependability. Next, for the previous project 4, which is automated fertilizer mixer system for fertigation farming. The advantages of this project is saving in both productivity and time and maintaining the consistency. And for the disadvantages of this project, technical knowledge and reliance on technological advances. And last but not least, the previous project 5, which is development of an IoT-based automated fertigation system. And for the advantages of this project is monitoring and control in real time. Secondly, enhance resource efficiency and time savings and automation. But for the disadvantages of this project is initial investment and infrastructure needs. Secondly is technical knowledge and management. So this is the conclusion for literature review. So as we can see, the important things that we can highlight from the previous project is it is possible to figure out that the key characteristic of design for smart plant fertigation with IoT based system are the database navigation system and water supply to the plants. Without these two functionalities, the fertigation system will not be able to reach its maximum potential. The use of IoT-based technologies and several sensors in smart plant fertigation provides several benefits for efficient and improved plant culture. Now we will go through to the chapter 3, which is methodology. So we'll start the chapter 3 with the introduction, which is this chapter summarizes research approach for smart plant fertigation using IoT-based device, focusing on data-driven decision-making, intelligent automation, and ongoing improvement. The system combines sensor technology, data analytics, and remote control capabilities, enabling farmers to increase crop output, preserve resources, and promote sustainable agriculture methods. So this is the 3D layout of the project that I've been working on it, and I use the software Tinkercad to initiate this 3D layout. So this is the 3D view of the design and front view of the design. And next, as you can see, the side view of the design and the top of the design. Next, we go to the pictograph block diagram. So based on the figure on this slide, there are several sensors that I use to run this project, which is pH sensor, DHT22, ultrasonic and soil moisture, ESP32, relay, water pump, and the Blink apps. So this is the explanation of the pictograph block diagram. The fertigation system diagram demonstrates a comprehensive system integrating sensor, microcontroller, and a mobile application for automated control and monitoring. The ESP32 microcontroller is central, connected to DHT22 pH, moisture, and ultrasonic sensors. The system communicates with a Blink mobile application for remote monitoring and control. A relay controls a water pump for irrigation purpose. Next is flowchart of the system, and as you can see, this figure shows how this project will run and works. And this is the explanation of the flowchart. So basically, the project uses DHT22, pH, soil moisture, and ultrasonic sensors to collect the data on temperature, humidity, pH, and water levels in tanks. The ESP32 microcontroller processes the data and controls the water pump, supplying the right amount based on the plant demands. The system is linked to the Blink app, allowing remote monitoring and control, resulting in accurate fertigation, improved plant development, and reduced resource waste. Next is simulation circuit diagram, and as you can see, this circuit diagram have been created using the software Printzy. And this is explanation of simulation circuit diagram. The fertigation system consists of the HT22, pH, soil moisture, ultrasonic sensor, relay, ESP32 microcontroller, water pump, and Blink app. The ESP32 process sensor data, operates water pump, and communicate with Blink app for real-time data and control choices. This simulated circuit diagram helps understand the system operation and integration with the Blink app. So next is the list of hardware, which is this is the several sensor that I use in this project, which is Node MCU ESP32, pH sensor, DHT22 sensor, and ultrasonic sensor. And last but not least, the soil sensor, relay, and water pump. So next we go to the list of software that I use to complete this project. So basically the Microsoft Office to do the report and this slide share, and Printzy for the circuit diagram, Arduino software to upload the coding, Blink application, and Tinkercad for the 3D layout design. And lastly, for the conclusion of the methodology, finally, using a combination of sensor and ESP32 microcontroller and the Blink mobile application, this project will successfully construct an advanced fertigation system. The combination of DHT22, pH sensor, soil moisture sensor, and ultrasonic sensor enable full monitoring of environmental variables in two tanks, including temperature, humidity, soil acidity, and water levels. The ESP32 serves as the central control unit, allowing the sensors, relay, and water pump to communicate and coordinate. The Blink program gave customers remote access to real-time data and control over the system, allowing for more effective fertigation process management and correction. This project demonstrates the power of combining IoT technology and mobile application to provide a smart and automated fertigation system that improves comfort, accuracy, and production in agricultural activities. And last but not least, the final year project to planning. So firstly, uh, I will do the hardware installation and prepare the prototype. Secondly, do the testing on the site, which is before and after implementation. Next, get the result on effectiveness on the system. And lastly, to achieve the objective of this project, which is able to monitor on Blink apps. So that's all from me to present my final year project 1. Thank you.